Here. So I'm going to give an overview of ML Commons, which is the organization that runs MLPerf. And MLPerf, as you'll see in a few moments, is the industry standard set of benchmarks for machine learning. This is kind of what we're going to walk through, right? What is ML Commons? Why are we doing benchmarks? Why are we building large data sets? Why are we building best practices, and what's next? And then interactive discussion at the end, where I have a few questions for the audience. So start stage one. Everyone here is probably somewhat aware of the innovations we're doing in AI and ML as a community, right? Some of the things I'm really excited about are, in 2019, I was in Beijing, and I do not speak any Mandarin, yet I was able to get around and order dinner on my own in a mall using my phone. And, that's really cool. That's powered by ML. Right, you see Teslas on the road. There's the promise of self-driving cars, which could save tens of thousands of lives. You've got AI in medicine. The potential impact for ML is huge, and really exciting for the entire community. And it's a big market, right? I probably don't need to tell you that there's billions of dollars out to be made there, if the motivation of saving lives isn't enough for you, right? Obviously, we're all in favor of making money and improving the world while doing it, but it's a big market. But one of the things I want to point out is machine learning is really a technology that it's in its infancy, right? If you think about this compared to flight or compared to electricity, we're still very much in the early days, right? If you look at some of the early planes, there were people who were saying, hey, we're going to make a plane that kind of looks like a bicycle, and you ride the bike and it flaps its wings like a bird, and you're going to take off and fly. Now, as it turns out, the 737 works on slightly different principles, which is fortunate. But we're still in those early days where it's not actually super clear what the standards are going to be, what the best practices are. For those of you who follow ML carefully, it's within the last 5 years that we saw the invention of transformers, which are very common in natural language processing, but are now being used in other areas in an exploratory fashion. How that ends up, we don't know yet. That page of the book has not been written. And that's kind of the point, which is if we want to go from handcrafted ML, where it really is kind of a black art, to something that's widely accessible, we need things that are more like interchangeable parts. We need the maturity to build and democratize AI and ML across many, many, many more companies. And so that's really what our goal is we want to provide that infrastructure, those building blocks, and help accelerate the growth of the industry. And so if you step back for a moment, when we started ML Commons, the first question was, okay, why make another organization, right? There's lots of industry standard organizations. There's the IEEE. They do a great job on collective engineering. You've got the Open Compute Project. They also do a great job on engineering. And then you've got AI and ML organizations that we looked at. You have the Partnership on AI. Now, they're very policy focused. So what we found is that there actually was no organization at the intersection of the Venn diagram that was focused specifically on ML and collective engineering. And so that's the organization that we built and that I have the absolute pleasure to lead. We are a global organization. These are the logos of our member companies. So we've got 6 out of the 7 continents covered. If anyone knows a company headquartered in Antarctica, please see me afterwards. Or if you know an academic station down there, right? I'd really love to hit 7 out of 7 continents. And we actually were started jointly by academics and industry. And so the first people in the first meeting for MLPerf was half academics, half industry. And so we have this very strong academic heritage.
So David, is the funding for ML Commons come out of the member companies?
Correct.
Or does it come out of the, let's say, benchmark auditing process, or a combination of both?
It's a great question. So all of our funding is from member companies. And so we have 2 tiers of membership. There is small companies, which is more than 10 people, less than 500. Or if it's a relatively new company that is over 500, it's also small. So first 5 years. And then if it's larger than 500 people and over 5 years old, then you are classified as a large company. And so, we were really lucky. MLPerf predated ML Commons by a fairly significant margin. So getting a lot of the founders to join us was not a problem. We've got a great roster there. The academics pay nothing. Small companies that are under 10 people pay nothing as long as they are, reasonable, right? We don't want like 5 guys in a shed with nothing to their name, but like if you have a legitimate startup company, we're not in the business of trying to make money off of, a pre-seed company, right? We want to see everyone flourish. Yeah, and so we've got a great representation across the community. So stepping back, the goal of ML Commons is making better ML for everyone, as I said. And, I really see us as having 3 pillars to that. One is benchmarks and metrics, and that's most prominently MLPerf. There are other benchmarks we're looking at. There's building large open data sets. To me, data sets are really the raw material of machine learning. And so, the bigger the data sets we can get,
unbiased, of course. Unbiased, of course, David. We had
right. And so that actually gets into a great topic, right? Which is that bias in many cases is a function of your data set, right? Like we are all lucky enough, or at least I'm assuming most of us in the room live in the United States, right? We live in, okay.
No.
Most of us live in the United States, right? And it's the most commercially significant economy. And so we have tons of data on what people in the United States do, right? But like,
no, it isn't.
So you say stove, right? You're going to visualize a stove that you might find in a condo or a house here, right? But if you say stove and you're in parts of India, you might actually be visualizing a tandoori, a tandoor oven, right? Totally different thing, right? And so, those data sets are what we need to empower the broader community, right? There are a lot of proprietary data sets, but if you want to democratize AI, you need data sets that are open and commercially usable for many people. And then the last part is best practices. And to me, best practices is about removing friction. And right today, ML is filled with all sorts of friction, right? We had folks earlier this morning talking about some of that related to storage performance, but there's plenty of other problems. Like even if you have a neural network that you've trained, simply deploying that in an efficient fashion is a process that may take you weeks, right? And when we can remove those frictions, then we're going to see the industry move forward and faster. And underlying all of this is research, right? We want to be doing, looking at new things that we can do that will make the industry better.
A couple of quick questions. One is, who do you count in your everyone? And the second one is, can you tell me what you mean when you say democratize?
By everyone, like everyone in the world, right? Like ideally, I would like for ML, I would like for everyone to be able to reap the benefits of machine learning. So if we're making a data set, right, ideally it will help everyone across the globe. Making machine learning solutions faster for training will help us and help everyone who is doing ML run their experiments faster, which will get us more innovations quicker. This is not I only want to aid and abet, the United States or any particular country. We're a global and open organization, so we welcome everyone and really want to benefit everyone.
So David, how would you contrast ML Commons with something like OpenAI, which is also trying to democratize AI?
So my understanding is that OpenAI is, to a certain extent, there's like a nonprofit element of it and there is a for-profit element of it. So they're working really hard on and very focused on NLP as well as sort of AGI. First of all, we are 501c6, so structurally we're an industry consortium. That is not how OpenAI is set up, to the extent of my knowledge. Right, there's a for-profit component, so that's going to be standard for-profit company. So I believe there is also a nonprofit component, but we are not out there raising money. OpenAI does amazing stuff. They have a pretty extensive staff. I have on the order of like 7 engineers. I think in many respects, they're fellow travelers, right? I think their goal is somewhat similar to ours, although, again, there's no profit motive for us. For me and for my organization, victory is how do we make the pie bigger for everyone?
I'm familiar with MLPerf from the benchmark perspective, but I guess I hadn't realized that you're also involved in data set governance and generation, as well as best practices.
Yeah. So actually, it's interesting. There is a real, I hate the word synergy, but there is real synergy between doing data sets and benchmarks. So,
oh, yeah, absolutely.
Yeah. And I'll talk a little bit about that in a moment, but to steal some of my own thunder.
It works that way because if you build your own data set, you know how to improve performance on it.
Right. Well, actually, I mean, one of the issues is that
standard across multiple instances, effectively, and stuff like that.
Well, one of the big challenges we actually ran into is when we started, one of the benchmarks that we wanted to have was for speech to text. It turns out that at the time, there were not very large data sets out there. There's like multiple orders of magnitude difference between what you could publicly get and what was considered industrially relevant. And so for example, when we started, there was, the largest public speech data set is on the order of 1,000 hours. That is not enough to train an end-to-end speech recognition network. And so we said, okay, well, we need to fix that if we're going to make a commercially relevant benchmark. And so, one of the differences between machine learning and some other benchmarks is in other benchmarks, you can probably get away with bogus data, but in machine learning, you cannot do that. So let's talk about why benchmarks. So to me, there's a couple points to benchmarks, and some of them are a little bit subtle. We all know that you use benchmarks to beat up your competitors, right? We see that.
Huh?
But in many ways, I think the most important thing is actually driving alignment of what it means to be better, right? And when we started MLPerf, we would see people making comparisons that made no sense. And if I can make an analogy, it would be like someone comes to you with a car and says, I have a car that goes 200 miles an hour. Next guy says, I have a car that can turn a corner in a quarter of a second. And, an intelligent consumer like myself might say, hey, I live in San Francisco. I can't go over 40 miles an hour in this city. And if I blow through a stop sign that quick, I'll kill someone. So maybe that's not the right metric, right? Maybe the real metric is how quickly can I get to the grocery store and back, and what does it cost, right? And so we want good metrics. And the point of a benchmark is you end up aligning everyone, consumers, researchers, sales, marketing across the globe on what better means. Now, and once you have that alignment, you begin, as the picture suggests, rowing together and moving really fast. And so that's actually been something that's really exciting to see, is sort of that rate of progress that you can drive with this kind of agreement. Now, benchmarks aren't perfect. We all know this. And so, I kind of liken it to navigation. Am I going to be pointing us true north with my benchmarks? Probably not exactly. But we might only be off by 4 or 5 degrees and we'll be moving together. And that's the important part. So here's some press clippings on some of the ways that we're driving performance together. This is also some data on the first 3 rounds of MLPerf training. And yeah, the font's a little small, but the key point is we're driving performance quite nicely. So here's, hopefully this is fully legible.
Yeah.
Yeah.
So one of the things I wanted to do to show what benchmarks can do for the industry is I've plotted in green on the bottom the trajectory that you would expect from Moore's law. So, right, Moore's law says, every 24 months, we kind of double the transistor density. And so if you assume that that equates to performance, right, what is the performance boost you would expect over, about 2.5 years? And it's reasonable, right? You'd get 2.5x better performance, which is great. But if you look at the performance on the 3 of our benchmarks that have been with us since the start, we're seeing more like 16 to 30x performance gains, right? So way, way faster. We're going much faster than Moore's law. And it's actually, this even understates the performance because for both the blue and the red line, there is an asterisk. And what that asterisk would tell you, if you could see the fine print, which you cannot because it is off screen, is that we actually increased the accuracy requirement. So it's actually doing significantly more computation. So if anything, this is understating the performance.
David, it seems like things slow down after 2019. Is there a rational reason behind that? I mean,
The pandemic.
no. This is June. This is June 1st, 2019.
Right.
It's
So
almost like it's tracking Moore's law almost more correctly.
possibly.
Other than the fact it goes from 3.2 to 6.8.
So I'm going to dig into this in a little bit more in some future slides in this deck. However, what I will say is if we look at the points on here, so each one of these is around, all the benchmarks are submitted simultaneously. So this is like really 4 rounds of benchmarking. And so, yeah, you're right. The improvement from the first to the second round is pretty big. And if I had to guess, I'd say it's because, you know, you've got a lot of low-hanging fruit to pick. Now, I will talk about some of the nature of that low-hanging fruit.
So this is,
Yeah.
let's say the masks are CNN. So that's an average of all the benchmarks?
No. Okay,
This is the
so we do
top
not average our benchmarks.
Or
That's a
the
great question.
worst benchmark? Or is this a
No.
median benchmark? What kind of a benchmark is this, David?
So the benchmark suite that we have, there's 6, depending on the suite, there's in the neighborhood of
4 to 7, something like that.
yeah, about half a dozen benchmarks. Each one is different. So this one, so ResNet 50 is image recognition. SSD ResNet 34 is a object detector
Yeah,
with a ResNet 34 backbone. And then Mask RCNN is a more complicated and computationally expensive 2-stage segmenter. And so these are all vision benchmarks. The vision ones are the only ones that have been around in every round. So 3 different benchmarks, 3 fairly different neural networks. And so that is the performance that you're seeing in terms of time to train for those 3. And so the factors that you're rolling up in here, right? 30x performance. First, Moore's law, right? We're getting better process technology. We're getting more advanced architectures. We're getting bigger systems. So some of the early MLPerf submissions were on the order of 30 or maybe 100 processors. Some of the more recent ones are more like 500 or a couple of thousand, right? And then you've also got improvements in software, right? The software stack here is truly massive. It's, you know, how are you tuning PyTorch and TensorFlow in sort of a higher level linear algebra sense with maybe something like XLA. You've got very low level linear algebra libraries that are going to be spitting out kernels for your accelerator or your CPU. So you've got improvements in networking as well. So there's a lot of levers that you can pull to get this, that got us to that 30x performance.
And for instance, the Moore's law line, is that cores? Is that transistors?
That would be picking the starting date, assume Moore's law holds, and that is essentially the increase in transistor count you should get, according to Moore's law.
Okay.
Yeah.
So that first value then, was that the first test?
Mm-hmm. That was the first round of benchmarking in the end of 2018.
So there was some initial gains then after that first round, and then it flattened out a lot more, didn't it? So
yeah, I think that's fair. And again, that's on these benchmarks. Now we're also introducing new benchmarks, but I don't have the full history for those, right? So like our current recommendation engine was introduced
A couple of years ago, right?
yeah, a couple relatively more recently. BERT was so for example, 2 of the oldest NLP benchmarks we actually pulled out. So we had a transformer based one and then a recurrent neural network based speech and NLP ones. And those were both replaced by BERT large. Right. And BERT is of course a cousin of GPT-3, right? So we've added and removed benchmarks. And that's one of the other challenges about ML. Everything changes so fast, right? What was state of the art when we started may no longer be state of the art. And so we actually expended a lot of effort in making sure we talk to customers and folks in academia to make sure that we're generally doing a good job of staying relevant. So diving out and stepping back for a moment, this is the set of MLPerf benchmark suites that we have. And they're roughly arranged from sort of highest power level to lowest power level. I like to joke we've got everything covered from microwatts to megawatts. So the biggest MLPerf submission was in MLPerf HPC. And the folks at Riken in Japan actually submitted using half of Fugaku, which is the world's #1 supercomputer according to the top 500. Only half of it. Yeah, it turns out supercomputing time costs something. So, you know, maybe next time. Anyways, Satoshi is fantastic. This is the gentleman who sort of led that effort, and I was like super thrilled to have him involved. And I think they were really excited to have real workloads. We've got training. I just showed you data from MLPerf training. That's sort of more commercially oriented training benchmarks, whereas HPC is really about scientific problems targeted at large scale supercomputers. We've got data center and edge inference, which use many of the same networks, but again, you know, sort of different metrics in some cases. We have a mobile app on both Android and iOS currently. And actually, if you're interested in running it, we can potentially give that to you if we get contact information. And it is, I believe, booting on Windows, but not yet productized there. And then we have a set of IoT-oriented benchmarks for MLPerf Tiny for, you know, embedded microcontrollers doing like wake-up word detection and things like that.
And these sorts of benchmarks, for instance, would run on standard GPUs, but they could be running on FPGAs. It could be running on Cerebrus solutions. It could be running on just about anything you want to throw at an AI training or inferencing.
More or less. So I would say broadly speaking, that's true. So for HPC training and inference, those the rules of the benchmark are actually very flexible because we want it to be fair and useful. And to me, fair means that, you know, Cerebrus, you know, as well as NVIDIA, as well as the CPU, as well as an FPGA are on a level playing field. And so we allow people to actually change the benchmarks to a certain extent to optimize to their architecture so that we aren't implicitly picking winners. Some things don't make sense to run on different things. So like the mobile benchmarks use TensorFlow Lite, probably not going to run that on like a data center GPU. And the IoT benchmarks are really designed for, you know, low-level microcontrollers, probably not going to run that on a high-end processor either.
But it might be fun to see like how Fugaku runs IoT Tiny, you know, I mean, that'd be great.
You might be able to get them to run it on a node. Yeah.
And another thing that occurs to me is that for some of these devices, they're really standardized devices. So you kind of don't need to run the mobile app on iOS except once, because once you know how it performs, how the mobile works on the iPhone 14, for example, you don't need to run it again, right?
Oh, I disagree completely.
Updates.
Yeah, software, hardware.
Well, okay, how about this? I don't need to run it.
Yeah,
You just need to run it once, and then we know how, for the whole class of devices.
Yeah, I mean, okay, so for smartphones specifically, there's actually a lot of complexity in the software stack because you'll have driver updates that may or may not be delivered over the air. You could have upgrades to the OS that may or may not be delivered over the air. That could depend on your carrier. The mobile stuff actually turned out to be a surprising headache. Like one of my assumptions going into this is, well, we tackled inference. Great. Mobile's like an easier version of inference, right, guys? And, you know, it turns out, yeah, the networks are smaller, they're simpler, they're not as you know, computationally demanding. But man, the mobile ecosystem is really messy.
I think a lot of that is because they have so many OS algorithms in there, which change every time they upgrade the OS and change whether you're in a low power state or high power state or of the battery. So how the device operates changes as you use it in terms of how much resource they give. Because I know, for example, the iPhone, when it's in a low power state, it changes its behavior.
Yeah.
And how much resources it's going to allocate to things.
Yeah.
So depending on your battery level.
I think that can apply to an awful lot of the performance graphs that we're showing in general, where it's not only Moore's law that's actually driving how the performance changes. It's the interaction between the components and the ability to potentially offload some of the capabilities onto other pieces of the system that aren't just central processing. And so, I looked at that, and it's not terribly surprising. Performance is going to increase faster than Moore's law because there's all sorts of other optimizations, both hardware and software, that are going into all these products as well.
Yeah, no, that's right. And like different, I have certainly seen that, even within the class of mobile phones, right? Some networks are easier to offload to certain accelerators than others. And, there was actually a paper a few years ago by some of the folks at Facebook. And one of the things they were saying is that for a challenge specific to mobile phones is I've got a new phone, brand new phone. But there are billions of people who have old phones that don't have effective GPUs, that do not have neural network accelerators. And so you must have your core features running on a CPU in order to deploy them across the whole world. Now, you get a faster phone, yeah, you can do more things. But that really does sort of color things. Now, the nice thing is that, if you look in the last few years, most high-end phones do have acceleration, which is great. We've, I think, done maybe a small bit to help drive that. But, you can get networks that you can't necessarily put on the accelerator and you still have to fall back. And then last, we've got a nascent storage focused group that is looking at building benchmarks specifically for storage solutions targeted at ML. One of the things we found is that in a lot of these large systems, especially for training, people will build out large computational clusters and then the storage may not be able to keep up. And so, how do we help customers understand what is the right storage solution? Is storage different for training an NLP network versus a recommender versus vision? Answering questions like that. There's a lot of interesting things to be studied.
Speaking of storage, David, it would be interesting to see the MLPerf results indicate more of the infrastructure than GPUs and CPUs and some software select stack elements. Storage would be great to have. It's just not available as far as I can see.
Yeah, so I think as a general principle, our goal is that the information on our site in the results should be sufficient to reproduce a submission. Now, so I'm going to go pick on NVIDIA for a moment. I don't like picking on specific people, but NVIDIA is maybe an easy example here, which is if you have a DGX, right, that comes with a certain amount of built-in storage. And so, we're not.
Even a DGX can have different storage configurations.
Yes, so that should be, if it's relevant, it should be documented. It may be that the storage configuration is not performance relevant, right? Aside from, do you have enough room to store the data? I don't know, for instance, if the configuration options within a DGX, if they can vary the number of SSDs and the bandwidth you get out of them. It's a good question.
Are you familiar with Cloud Physics, the company? Cloud Physics was a company that was around probably 7, 8 years ago.
Okay.
And what they did was they actually built out a very wide-based database that covered all sorts of various different configurations that have put together.
I see.
And actually it wasn't just like this aspect. It built out a full database of all the various configurations and also listed the type of performance type metrics that you get at that. It wasn't just measuring ML type performance, but it was a matter of, they built out what they claim millions of different configurations, various different things, and with various different data on those configurations.
Yeah, so the submissions for MLPerf will be for a single, however many configurations like the submitter, the vendor, wants to do. And it doesn't have to be the vendor, right? If you actually look at our results, there are cloud folks who are submitting plenty of things. There are some end customers who are, buying servers and potentially submitting them. But doing something like a kind of more exhaustive search like that would actually be quite time consuming. I mean, to give you a rough idea, For MLPerf training, the approximate runtime of most of those benchmarks is going to be about a week using a single V100. You know, now obviously the runtime for the whole benchmark might be a couple minutes or even less, but that's if you're using many, many, many compute devices.
I mean, what I was simply pointing out is that they made a point of gathering data from various different people and storing the exact configuration, which I think along the lines of what Ray was.
Yeah, I think we could do a much better job on documenting the configuration.
Yeah, I think
That's
they've
been
got
an
the
internal
information,
fight
they're
for
just
me.
not less necessarily publicizing.
Yeah, I mean, we should talk about this later. Like,
Okay.
this
Yeah.
is something that I actually very much want to improve. And it's sort of a question of like, how do we get the submitters to pull together the disclosures and all of the configurations?
And do you audit the benchmarks, or how does that
Great,
work?
great question. So these submission rounds are all done at the same time for that exact reason, which is that they're all peer reviewed by everyone else. We do have audit for the inference and mobile benchmarks. You don't need to audit in the same way for training. But yeah, so we do have audits. It's all peer reviewed. And, you know, it's not uncommon that you will find that there is a mistake. You know, this has happened and those get corrected if they're, you know, particularly.
So on the training thing, you're dependent upon accuracy metrics based on the data that's generated during the training sessions. Is that?
Yeah, so you have to hit a target accuracy.
99.0 or
No, I would be, so like an example of a training accuracy would be like 75.9% top one image recognition. And so you have to hit that, and that's when you've finished the job. That's when you hit time to train.
and that would not require auditing because it's
No, it'll be evident from the logs. Like you can just rerun it. It's conceivable someone could submit bogus logs, but that would be discovered incredibly quickly.
Is that the benchmark you're looking at then, how long it takes to train?
Exactly.
It's
Yeah, it's
time
time
to
to train. And for inference, it's like time to do inference or inferences per second. You know, sort of
Okay.
depends on the exact scenario. We have 4 different scenarios. But yeah, and so again, actually, a lot of this stuff is very easy to reproduce. Maybe not exactly, but you can certainly. I mean, some of the things, right? You know, if it's something that's commercially available in the cloud, right? You just show up to Google or Azure and say, hey, you know, here's $1,000. I want the system. I'm going to run this code, and boom. Will you get the exact same result? Not necessarily. Machine learning is unfortunately intrinsically variable, especially on the training side.
a lot of it's randomized, you know, to some extent, right?
Right. Yeah, you have random initialization, but you know, that's why the benchmarks are run like 5 to 10 times. We average the results. So it should be reproducible within a window. So, you know, if you are reproducing something and you see performance that is like at a 30% delta to something that is on there, that's a problem. I mean, we're targeting plus or minus, I think, 2.5%. Whoa. And so the other thing I'd mention is, you know, the benchmarks are actually used for procurement. One of the areas where that, you know, is a priority for me is figuring out how I can enable more customers to use the benchmarks productively. You know, that's just a project. So I'd love any feedback on that.
Just one on the training one. Are you doing any comparison with how accurate the training gets compared to the time? Because obviously, if you can only train, you might train it really fast to 70% accuracy, but it might take a lot. There might be a longer way, but you get it to like 90% accurate. So,
And also, somebody who's actually trying to use this to make a purchasing decision might be willing to sacrifice some accuracy, or might want to spend up to get more accuracy.
I'll spend more time, but get
Either way.
And those are the kind of questions they might be wanting to answer through MLPerf.
Right. So the accuracy is a fixed target in order to measure speed. One of the things that is challenging is that there is a nonlinear relationship between accuracy and performance. So there is a very long history of doing what I would call accuracy benchmarking in the academic community. And so we've sort of felt that was a need that was very well addressed by a lot of these competitions. And so what we wanted to do is really pick an accuracy target that was very close to state of the art, and then say, hey, beat that, and measure the speed as a function of that. Now, there are, for inference, we allow small degradations in accuracy, so under 1%. And so you will see people competing on that within a certain realm, right? Which is you might, like I know there are some submitters who have specifically made submissions where they don't do quantization because that's how they think it's most valuable and most appropriate. But the accuracy is a primary, we think of that as quality. Quality as a primary metric is something that is outside of ML.
I think the other thing that's impressive about MLPerf is that all your models, all your data are all open source. They're all on GitHub. Anybody in the world can go out there and just bring them down and start running them on your laptop if you wish.
Yeah, the reference models are, right? Like now the reference model defines correctness, but the model that's going to be best for NVIDIA or Intel or AMD or Cerebras will be a little bit different. But they're free to go ahead and post those, and that's part of the point is that unlike most benchmarks, everything we do is by default open source. Now you can use proprietary software in your solution, right? Obviously, there are lots of folks who have closed source drivers and other system software, and so we do allow for that. But yeah, we want things to be as open and reproducible as possible. In part, so that if you're a customer, you can go grab the MLPerf submission and see, hey, this is how I tune things. This is what I should run. It, to a certain extent, represents the vendor recommendations.
Yeah, it's almost like reference architecture for all these models.
Exactly. All right. So talking about shifting gears to data sets. One of the key points I want to make is if you look at the history of ML, right, what really catalyzed everything in ML, at least this last go around, was ImageNet and the discovery that convolutional neural networks executed on a GPU could beat humans at image recognition on ImageNet. ImageNet cost about $300,000 to do. And so it's not a trivial amount of money, but it's really not that much money. If you think about the ROI, it's incredible. Now, the challenge is that most public data sets have the unattractive characteristics on one side of this screen. They're not very big, especially compared to what someone like Google might have internally. They're legally restricted in many ways. So you may not be able to build a commercial product on top of that data set. They're not redistributable. We actually ran into that problem with some of our benchmarks. So ImageNet itself is not redistributable, for instance. You probably should not use it commercially either, but talk to your own attorneys. And as we were discussing earlier, right, a lot of them are not diverse, right? Like when you look at a lot of the image data sets, they're generated in the Western world and are not representative across of the whole globe. And they also don't change, right? So, just think about like what it would be like to have a speech to text system that can't do COVID, coronavirus, or any things like that. Like you need these data sets to evolve because that's the real world we live in. And we want them to be large, easily usable, et cetera.
So do they not change because people have done it and they think they're done? Or like, what do you think causes that when you say they don't change?
So part of it is a lot of these data sets are built by academics. So, and if you think about like ImageNet's a great example.
Yeah.
Right. So like, I think it was Fei-Fei Li's group came together, they built it. The graduate students graduate, projects are orphaned.
That's what I mean. They're
Right,
done.
yeah, and so-
either it's funding or they build it for a special purpose and then set it out free to the world.
Exactly.
Or they could be using it as a baseline for something that they're putting into production, something where they can't necessarily improve the learning board.
I was just trying to get to the reason. Since we're
Yeah,
doing
okay.
this is how it's done wrong, this is how we
Yeah,
think it's done right. I want to know why things went wrong.
Yeah.
And I
part of
think
it
like
is
a-
look,
I think an awesome set of data set would be like the tech field day recordings.
They might be
it-
I
biased.
know where you could find that data.
you have to talk to the owner of the recordings to talk about licensing.
Yeah.
Copyright.
Yeah, no, but I mean, so the reality is that building a data set is sexy and fun. You'll get
Yep.
papers out of it. Maintenance, not so much.
Yeah.
Right? This is the classic engineering problem.
Yeah.
Right. So actually, ML Commons, part of what we want to do is we want to be the gardener for the garden of data sets. Right. You got to yank out the weeds. You got to plant new stuff. You got to fertilize the garden. Right. And so that's our goal. So we have two data sets that we have built. First is focused on speech to text. And this kind of illustrates the challenge here, right? So first of all, voice interfaces are going to be available to almost everyone by the middle of this decade, right? Your phone has it, many smart speakers have it, smart TVs, et cetera. But if you look at, unfortunately, it's going to be a little hard to read this, but there's great coverage for languages like English and Mandarin. But you start dropping off from there, and it's actually really, really, really tough.
So are there, well, I guess that's a loaded question, but I'll ask it anyway, admitting it's loaded. So are there any special initiatives to capture like what we consider dying languages, like indigenous peoples and I'm not talking about Latin. So
right. So there are, those are, we are not working with those, but I think the Mozilla Common Voice is doing things along those lines. But I think the tricky thing is finding the speakers.
Yeah, so that's why, I mean, and again, if you're building this data set just to help train models, then including a truly dying language where there's only 14 more speakers, you probably won't need that to train modern cell phone stuff. So this is my worry of the scope of the languages. Now, I'm going to use the word bias, but I don't mean it in the common parlance. I just mean it in the data way.
Yeah.
That there's a scope.
Yeah.
For the size of the population, like the smaller the dot.
Yeah.
How much does it solve your problem, but someone else using the data set might want it to include those things.
So the first data set we built,
Yeah.
English only. So 30,000 hours of labeled English speech. So when we started out, the largest data set, and I talked about this on the podcast with you guys, was about a couple thousand hours. And you need roughly 15,000 hours to train an end-to-end speech-to-text model. So we ended up with about 30,000 hours of speech, CC BY licensed. So you can use it commercially. Anyone can grab it off the internet, assuming they have a couple terabytes of storage space and some patience. We launched it at NeurIPS last year. And one of the things that's nice is actually this is kind of noisy text. There's like sermons, there's political proceedings in there. It's not just a clean audio signal like what I am giving right now, right? We've got a mic super close to me. Most people are not making noise. We don't have ambulances running by, but we really want to in the future. So first of all, get more diversity in terms of accents in different languages, and then also more realistic context, right? So let's go collect speech at a cocktail party. So second data set is, this one is, while the first one, I think about that as going deep in a particular dimension. Here, I think about going broad with the Multilingual Spoken Words Corpus. Most of you are probably familiar with keyword spotting, right? So, hey, Alexa, open the garage, put the kids to bed, go buy a gift. By the way, if your Alexa can't actually put the kids to bed, that's pretty awesome. You should commercialize that. Huge market for that. So that's keyword spotting.
You realize I have to go home now and close my garage door.
What?
Exactly. Everybody's garage door just opened.
Yeah, exactly. Oh no, I know. I mean, you have to sometimes be careful with that. And oops. But so we have keyword spotting in 50 different languages with about 23 million utterances. And so one of the cool things here is most of these languages, there is no existing free commercially usable data set. So, and some of these have a large number of speakers. So Ukrainian has 30 million speakers. There was no Ukrainian keyword spotting data set until we released this. And collectively, those languages are spoken by about 5 billion people, which is really awesome. So when I think about diversity, and breadth, this is really cool. When we released this, these are not dead or dying languages, but we got a lot of enthusiasm from Catalan and Basque speakers, right? Those are, very vibrant communities. but they're not huge. And so there is a lot of enthusiasm around this. And, we're maintaining this, we'll be improving it over time, and you can go on the web and grab it and use it for whatever you want.
So are you collecting existing recordings or sourcing new ones?
So this is extracted from Common Voice. So Common Voice is the Mozilla project I mentioned. And so they have a web interface where anyone can kind of go to their computer and, say something, right, and record it. However, just doing that alone is not sufficient to get the labels. That gets you audio. But so the key, and if you read the NeurIPS paper, it has details on this. But one of the key things here is getting the labels so that you can actually train with it.
Mm-hmm.
And so that means annotating things like timing, like when did you say this word? What is the word? And other things you may want to generate as well.
So obviously you say it's been maintained. Are you constantly seeking new material then? Because obviously language evolves over time and very fast.
Yes. So our hope is to have like sort of regular releases, and is it going to be once a quarter? Is it going to be every half year? Not sure yet, but definitely we want to maintain it and increase the number of the amount of data we have. So, and we definitely see line of sight to getting more data and broader data.
But David, your MLPerf benchmarks, many of them have various size data sets associated with them as well. You're not
Correct.
talking about those here, right?
So actually, if we go back, the original motivation for the people's speech was to get a data set that we felt would be sufficiently large for benchmarking. And so we may actually use this in a future iteration of some of our benchmarks.
Right, but your recommendation engine, you've got NLP, you've got
right. So
object detection, medical images, it goes on and on.
Yeah, no, there's probably about like 10 different data sets, maybe a dozen data sets that we use in the benchmarks. And I'll be honest, this was a major endeavor for our organization. I think we calculated how much we spent on this, but I think we spent on the order of $50,000 to build this data set. And I think our back of the envelope calculation was that to produce this via existing commercial tools, like to go pay someone to transcribe, would have been several millions of dollars. And so one of the core observations and one of the goals here is, hey, how can we use compute more intelligently to build data sets? But sometimes the data is just really hard to get. Like recommendation in particular, there's a boatload of privacy concerns around that. So I would love to build a commercially relevant sized recommendation data set. That is a very hard problem. So one of the challenges with ML, as I said, is there's a lot of friction. And one of the ways I like to highlight this is I talked about BERT was really a pioneering model in natural language processing. And I think it was in 2017, it was first published by Google. And it's totally changed the way linguistics and NLP is done. Everyone is adopting some flavor of BERT. But when it was released, it was a paper and a little bit of code in TensorFlow that Google had made. And so the first thing that researchers did is they said, hey, we want to go reproduce that result and see if it really works. But if you're at Facebook, you can't use Google's infrastructure, right? If you're at Azure, you can't use Google's infrastructure. It's going to look different. And so actually reproducing that, it turns out people made their own flavors of BERT, and it took about a year for that to happen. And my genuine estimate is it was probably 3 to 4 months of just like grunt work of porting things and getting it up and running. And so there's actually a lot of work to reproduce an existing system. And so one of our goals was how can we cut down that time to something like, maybe an hour. And so we have a project called MLCube, and sort of the idea is it's an extension on containerization. And the idea is we want containers to truly be black boxes where you just say, hey, I grabbed the container, I hit the train button, and sometime later the model pops out, train. And so it's a very simple, lightweight set of interfaces. And the idea is, again, to enable reproducibility for ML and portability as well. Now,
ML training and inferencing, or?
this is, you could use it for inference. It's probably most useful in the context of training a model, or even maybe building a complex pipeline. Actually, one of our member companies, they've been using MLCube internally for validation and testing tools for servers, just to get like better reproducibility. One of the challenges of something like Docker is you actually care about what's inside and you need to know what's inside in order to manipulate it. So having this sort of black box like interface is actually really, really valuable. So we have, it kind of works on a publish and run model. So you package something up into a MLCube and then you have runners for it. We have runners for local machines, for very wide variety of clouds, and for Kubernetes as well. And if you're interested, you can go to the URL and find out more. And I mentioned research. So some of the other things we're working on, we have algorithmic research, which is how do you improve the efficiency of training or maybe get better accuracy. We have a project called DataPerf that is in a very nascent stage, which is how do we improve accuracy, but not with better models, but by playing with the data set better. So for example, if we want to talk about vision, a very common thing is you'll start out with a set of images and then you might clip them, you might rotate them, you might distort them in different ways to augment the data set. And that will help you get better accuracy. And we want people to think about data as really a first-class citizen in machine learning. So how can we have different data modifications that boost accuracy and sort of have people compete there? One of the ones I'm really excited about is the medical research working group, which is focused on federated evaluation of medical models. So if I'm a researcher in Japan, let's say I have trained a machine learning model that can predict heart attacks. Well, the first thing I should do is see, does that work on a more diverse population? Can I run that at Cedars-Sinai in LA or Langone in New York? Because you can't move the data around, right? But how do you move the model in a way that is secure, you know, do the evaluation, get your results back and find out, oh, this does generalize, or maybe it doesn't. And so there's a lot of really exciting work out here. So that's really an overview of ML Commons. I'm a mere 12 minutes over, it appears. And yeah, now we're on to discussion. I did actually have some questions that I wanted to prompt for discussion, which is, you know, again, I'm here at an organization where our goal is how do we help the industry? By the way, I would be happy to share these slides. There's nothing NDA'd about it. You know, I'm
Well,
happy
that's good because it's live streamed over the internet.
yeah, you know, my social security number's in the back one anyways, you know. But yeah, so how can we help the press and analysts understand MLPerf? One of the things you mentioned is, you know, let's have more complete disclosure and description of the systems, like more complete system descriptions in our benchmark. You know, I'm out here to help customers and industry use MLPerf in different ways. Like part of the reason it's open source is we want people to be testing internally. So if you're developing a compiler or a math library, go get MLPerf, see how you can improve it. Like you don't have to pay us, just grab the code and do it.